part 2 in the series of my electric metal melting furnace, so I can start casting some of my own aluminum axe heads. General shape here is going to be octagon with a little inspiration from a couple other YouTubers, which I'll link below. I mean, long story short, we're cutting grooves into the brick here to hold our coils, to make sure that the coils stay in there and they are able to radiate enough heat into our crucible to get things hot enough. Now, the calculations I've done, we're aiming for about 3,000 watts, which should produce enough heat to melt aluminum at about 660 degrees Celsius. So after I laid everything out, I was able to place the coils, just make sure they're going to fit visually, and then get to where we need to be. So in the end, we're aiming for about 19 ohms. And with that much resistance and 240 volts, we should be able to heat up some aluminum in a relatively quick amount of time. So the one thing with this tile saw I'm using, it has a water feature where you can reduce some of the dust, but with these bricks, that water really does a number on the material. So I had to be careful not to soak the bricks too much. I had to make sure that the bricks stayed intact and didn't become too brittle. So in the end, I was able to kind of feather the water supply and get the grooves cut for the coils. And surprise, they fit in there pretty decently. In the end though, I actually needed another row, so you'll see that soon. So this here is a stainless steel connector that I came up with just to hold the coils in series. Looking back, if I were to do this again, I would keep the coil as one long length. Here's just a brief, terrible video of my electronics. Again, in the end, I ended up having to buy a new solid state relay because the one I got from Amazon ended up getting sent to me not functioning correctly. So I ordered a couple new ones. Again, realized I needed more bricks to make sure that my crucible fit. And then I would say the majority of this project was just me cutting fire bricks and cutting them correctly so that they all fit. Fortunately, I'm not great at the video part of YouTube yet, which I mean is the main part of YouTube, but as you can see, my son's life jacket was in the way. You get the point though. I was able to kind of cut the bricks and then break them apart. Like I said, they were a little brittle, but again, cutting, using a little bit of water, again, just keep the dust down. And then once they were all finished, with that tapered edge on the side, I was able to fit them into the keg and just make sure they fit properly. And then with my calculations, I was actually able to get the coil to the right length where it fit inside of the furnace. Here I used some of that K-wool around the outside of the bricks. So that's what's going to be mated up against the stainless. So hopefully it keeps the heat down and keeps the heat inside the furnace. Some footage that I wasn't able to keep because of my terrible skills was I put in some ceramic paper in between the bricks and the K-wool just to keep things tidy. So there are several layers inside of the keg. So it goes brick and then a wire retaining the brick, and then the ceramic paper, then the K-wool, and then on the outside is the keg itself. So hopefully the outside of the keg doesn't get too hot. After a little pep talk to myself, I switched the breaker and hit the power button just to see how things went. It turned on, things went well, and after realizing I need an entry point for some of the coil, I wired it back together, and then with the coil inside the keg, we got some heat. Now this thing pumps a ton of heat. Even just kind of hovering my hand over the top, we got quite a bit of heat. Without the lid though, we're not going to be able to keep any of that heat on the inside where it needs to be with the crucible. So here I took the top of the keg, I kind of marked out a few different circles. I was able to use a carbide drill bit on my drill press to get through the stainless. Just made it a little bit easier. And then I just slowly rotated the keg top around. Now the reason I'm doing this is so I can thread some of the stainless steel bolts that I got, just to grab onto with the refractory cement. If you don't have anything to grab onto, that keg on the inside is quite smooth, and so that refractory cement will just fall out eventually. One thing that is a little questionable on my end is I had some leftover K-wool, so I tried to use some of that K-wool on the inside of the lid, again to retain some heat and to also make it so I didn't have to use more refractory cement than I needed. Now I put the K-wool down first and then the refractory cement on top, and was able to kind of push the refractory cement into these stainless bolts. Now hopefully that's able to hold and the stainless bolts can retain the cement. So here I just tighten up all of the nuts. I also placed some stainless steel wire around the top of the bolts, and then doing that I kind of hope to retain some of this cable and give the refractory cement something to hang on to so it doesn't fall out in the future. Also make sure that you put something in the center just to maintain the hole so you can add more metal into the furnace without taking the lid off completely. So what I did next, I just smoothed things out, made it as flat as I could, tried to push it into those bolts just so it grips onto it, and then spread things around. So after this lid is completed, I have to let it set up for a few days. I'll have to expose it to some heat just to set it, and then we're gonna put the lid on and turn this thing on. Thanks for watching. Stay tuned for part 3.